Hello all and welcome back. So in this video, let's find the time complexity of another algorithm which we have done, the bubble sort. Now in the videos which will follow, I will be doing so many questions with you so that towards the end of it, you get a lot comfortable in finding complexity of any algorithm. So let's get started. Now in the bubble sort, we were again given an array or a list and we have to make sure that we are sorting that, right? Since we are talking about the big O time complexity, always remember that you have to carry out all the steps, right? In the worst example, in the worst test case will be one in which everything is sorted in a decreasing order, right? So let's say this will be something like this: 5, 4, 3, 2 and 1. So that you will be actually making sure that you do all these things, right? The same is something which we saw when we were finding out the maximum of an element. So let us go to the code as well. Bubble sort, we have the code with us as well. This is the bubble sort code, right? So pay attention everyone, what exactly are we doing here? Now this is some k operation or some constant operation of just finding the length. So I'm going to take it 1. Now here at each iteration inside, right? At each iteration inside, what I'm doing is, I am doing some k operation again, right? So let me just remove everything and explain you again. What I'm doing is, these are the k operations which I'm performing. Now since I'm taking the worst case, always I will be doing these k operations, right? So all I have to find is how many times am I doing this k operations, right? So let us understand this once. For the case when I am on the first element, okay, when I goes from range 1 to n, so for when I will be equal to, let's say 0, my j is going to get run for n minus 1 times, right? So it's going to run for n minus 1 times. So that means that I'm going to do this operations k times, n minus 1 times I'm going to do the k operations, right? So what I'm saying is, for initially this I is going to be 0, right? J will then run from 0 to n minus 1, as we can see in the code. So the code is in front of you and we are doing this k operations. Again, we have to always talk in terms of k, never in time. Exact time we can never calculate, okay? I will keep on iterating this point so that you never make a mistake in any interview, in any OA, in anywhere, okay? So that you're always having the best knowledge of this. So since this k operation will be performed when I will be 1, again j will run for n minus 2 times and this is going to be my k operations n minus 2 times. Similarly for 2, it's going to happen for n minus 3 times. Now, if I just add all of these operations, the number of times they're going to happen, I should be all set to find out my complexity. So let us see this once. Let me write it here so that your notes are actually also completed. So we will be just shifting and comparing and swapping these elements, right? So what I'm going to do is, for first element, I'm going to do this operation n minus 1 times. Okay, so k operations n minus 1 times. Again, I'm not taking that n is equals to length of array constant time operation, as we have now seen already that we have to do this just for the highest terms, right? Then for second element in a similar way, we will be doing it n minus 2 times. Again, for third element, n minus 3 times. Finally, when I reach for the second last element, on the second last element, I will be just doing k work, right? Just comparing with the last element. So all I'm saying is, when it will be n minus 1, so it should be n minus, so what I exactly meant is, when in the last iteration, I will be equals to n minus 1, okay? And j will just then be equal to 1. So it's going to run for the last time, right? It's the last one, sorry. Second last will be n minus 2. So this goes from 0, range n goes from 0 to n minus 1, right? So the second last is going to be n minus 2. This time j is actually going to be run from range 0 to 1. So it's going to run for the last time. For the second last element, for this second last element, I'm just going to do the k operations with the last element. These boundaries are also very important to understand. So please make sure that you actually don't make a mistake in this. I will repeat this again. When this will be second last, my I will be n minus 2. Since j is n minus 1 minus I, it will be equal to 1, and this will run from 0 to 1, right? So j will just run one time. Range 0 to 1 is just 0, and I'm going to do these k operations. Okay, so I hope this is clear. Again, make sure that these boundaries are also clear a lot. So for the second last element, I'm going to do this k operations, right? Now all I have to do is just add these and tell actually how many operations I'm doing. So let us add that. If I add them, it's going to be k into n minus 1 plus k into n minus 2 plus k into n minus 3 all the way till final k. Now here I can actually take the k common and then write it something like this: n minus 1 plus n minus 2 plus n minus 3 all the way till 1. Okay, so for those who are not aware, this is actually a very good pattern. So we have the formula for 1 plus 2 plus 3 all the way to n, which is equals to n into n plus 1 by 2. Now if we just see this closely, this is just in the reversed format where we are doing 1 plus 2 plus all the way, but we are going till n minus 1. So if in this formula I just change n with n minus 1, I think I will get my answer. I will get the total operation which I have done, which I believe will be equal to something like this: n minus 1. Okay, so changing n with n minus 1 and n minus 1 plus 1 by 2. They will get cancelled. It's going to be n into n minus 1 by 2, right? Now these I can add k as well because k is something which I took common. I can further extend it. Further, if I extend this particular expression which I have got, I can write it something like this. So k is going to be out only. It's going to be n square minus n by 2 by 2. K can come here as well. So let me just now have k with individual terms as well. Now if we will actually understand for a very large n, of course this particular part will surely doesn't have any significant, right? So for n, when n let's say is 1 billion, okay, I'm talking about 1 billion elements, then for sure this is going to be the dominating term and this will not be having anything, right? Again, that means that I can actually just assume or cancel it out. If this is the final relation which I am getting, which is kn square by 2, I can just do c dot g of n. G of n I can take g of n I can take just directly n square, and c I can take something, let's say k by 2 plus 1. So I have now created an upper bound. If I have created this upper bound, let me add another page. Okay, then I know g of n is something which is n square, and as we have very nicely understood about the big O complexity, my complexity finally is going to be O of n square, right? So let me write it as well. We will have complexity for bubble sort as big O of n square, which is quadratic. So this overall complexity is also a little bad. Like when we will have a very high input, it's going to take a lot of time. Something which we also actually saw, right, when I ran this code, if you all remember. So not this, the other one. Let me open it. Yeah, merge sort versus bubble sort. So when we ran this code, it took forever to give us the answer for the last one, right? I think it's still running. No, it's not that. So yeah, it took forever to give us the answer for this, right? It took so many seconds, and that's the reason. Like if the input is increasing, then the time taken actually increases a lot. So O(n) square is kind of some complexity which we will try to avoid if we can. But again, those things will get clear as we move forward, so it should be fine. Okay. Time complexity. Okay, quadratic time complexity. So we say that bubble sort is quadratic with respect to the input size. Okay, cool. I hope the whole understanding of how we find this is clear. I made sure that I show you the code as well here, because when you write the code, you should have an idea that, okay, from this particular code, how you can find the final complexity. Okay, everyone. So please make sure that you see and understand this. Again, don't ever remember the complexities. I have seen many students do this mistake where they remember these complexities. I feel that they are easier to find if you actually understand the process once, and that is what I would like you to inculcate in you. Plus, this will be a lot helpful if tomorrow you have to find out some complexity in an interview, right? In most of these FAANG companies, in most of the good product-based companies, they will always be asking you to find the time complexity of your code, the one which you have written, and the process. If you actually explain them the process, they will be more than impressed. Okay, so cool then everyone. Let's now meet in the next video. Thank you.